So in this video, we're going to talk about combustion heat problems, and usually these problems involve, chemical equation given with some sort of change in delta H for the reaction, and we got to calculate, how much heat is released. So I have this problem here. The reaction is given, a balanced chemical reaction is given, okay, and it says a gas tank in a home grill contains 13.2 kilograms of propane, okay. Calculate the heat associated with the complete combustion of all of the propane in the tank. Okay. So it says calculate the heat. So immediately I'm thinking of heat. I know my final answer has to be in kilojoules. Okay. Now I'm gonna start with what's given. So it contains 13.2 kilograms. So 13.2 kilograms of propane. Well, propane is C3H8. Okay. But notice that my answer is in kilograms. Okay. Notice that the amount of propane I have is in kilograms. So if I convert that to grams, and so essentially I'm using the fact that for every 1 kilogram I get 1,000 gram. Okay. And from this, look, I could use the molar mass to get to moles. Okay, because I need to somehow relate this idea to how much propane I'm gonna actually get. And so if I look at this, well, it looks to me as a 3 times carbon, 3 times 12, plus 3. So if I multiply these, if I look at the times plus 8, I'm sorry about that. So if I look at the molar mass for 3 times 12.011 plus 8 times 1.008, that will give me approximately 44.09. Okay. Now the molar mass, I need a molar mass, and so I need to somehow get to moles. I didn't somehow get to moles, and so I know my 44.09 grams will be on the bottom for every 1 mole of C3H8. Okay. And guys, essentially what I just said, I literally just found the molar mass for this. Okay. So I did the calculation. Okay. So I had to find the molar mass in order to get to moles. And here's the reason why. Okay. If you guys did not know, delta H, okay, in this case, it's given by kilojoules per mole. That's the idea. And so that's the reason why I needed to get to moles, because this answer, even though it just says kilojoules, it is actually kilojoules per mole. And so what does that mean? Well, I know that for every 1 mole, I know for every 1 mole of C3H8, I actually get negative 244 kilojoules. Okay, and so if I plug this all into my calculator, it should go around negative 6.12 times 10 to the 5 kilojoules. Okay, so that's the idea. I didn't have grams, so the calculation wasn't straightforward. I had to go to grams first, and then use the propane's molar mass. I had to use propane's molar mass to convert to moles, and then from there I could use my change in delta H of the reaction to actually get the amount of kilojoules that actually being released. Okay, and it should make sense. The answer should be negative because this is a combustion reaction. It's exothermic, so energy is leaving the system. Okay, so what about this one? We have acetone here, so C3H6O. Okay, and it says, the question says, if a bottle of nail polish remover contains 177 milliliters of acetone, how much heat is released by its complete combustion? Well, how much heat is being released? Again, we know the general idea. Now, the idea is that we're actually given the amount of acetone we have in volume now. And so if I look at this, I have 177 milliliters of C3H6O. Okay, well, notice that I'm given a density, so that's good. So I can go to the amount of acetone I have in grams. Well, the density says for every I'm sorry about that. The density says for every 1 milliliters, I have approximately 0.788 grams of acetone, H6O. Okay. So I have this amount of acetone in grams, okay? And so what else do I need to do? Well, how much heat is being released? Well, Again, I need to go to the molar mass of acetone. Okay, so I need to calculate the molar mass of acetone because I need to somehow get to moles. If I calculate the molar mass of acetone, 3 times 12 plus 6 plus 16 should give me about 58.08 grams of C3H6 of acetone for every 1 mole of acetone. Okay, so I had to use the molar mass to get to moles of acetone, and from moles of acetone we can get to kilojoules because we know the units of this. This is actually kilojoules per mole. And so if I look at this, for every 1 mole of acetone, I actually get negative 1790 kilojoules. Okay, and so from this, if I plug it into my calculator, I should get about negative 4.30 times 10 to the third kilojoules. Okay, and again, our answer should be negative because again, it's a combustion reaction, it's exothermic. So again, this is how we usually deal with these types of problems. The general idea is to get to moles of how much gas or whatever you have, and then just simply use the conversion of kilojoules per mole to get to kilojoules.